Hello students, in the previous video I had given you an introduction to sulfuric acid. So today we are going to see the manufacture of sulfuric acid in the industry, how it is done. So keep watching. Manufacture of sulfuric acid. The name of the process is contact process. So this is the name of the process. A question can be asked, what is the purpose of the contact process? The purpose is manufacture of sulfuric acid of required concentration. This is important. So if you simply say manufacture of sulfuric acid, it is incomplete answer. You have to say that manufacture of sulfuric acid of required concentration. Why do we say that? Because in this method, this contact process gives you any concentration you require. So you can prepare, you can already determine what concentration of sulfuric acid is required for you, and then you can get it. So that is it. So let us understand how it is done. What are the steps here? The first step is the manufacture of sulfur dioxide. The raw material required is sulfur dioxide. So first you have to make it. It is manufactured in the unit itself. The step one is the manufacture of sulfur dioxide. How do we get? Different ways are there. The first one is by burning of sulfur. Sulfur, when burned in air, produces sulfur dioxide. S plus O2 gives SO2. Sulfur dioxide is obtained in large scale. We have large scale resources of sulfur which can be burnt to produce sulfur dioxide. The second is by roasting of sulfide ores. Sulfide ores which are sulfides, the minerals of metals which are in the form of sulfides, which are roasted. Roasting is, what is roasting? Roasting is heating in the presence of air. That means you will have an open container and you will heat it. So it will burn and it will produce the sulfur dioxide. Here we have the various minerals here, the ores. The first one is zinc blende. Zinc sulfide is the main compound present in it. On burning or roasting, it will give you zinc oxide and sulfur dioxide. So how do you balance it? 2ZnO, 2ZnO, right? And 3O2, 2SO2. So it is balanced. So zinc oxide and sulfur dioxide is obtained. The second one is galena, which is containing lead sulfide, PbS in it, which also on roasting gives PbO, lead monoxide, and sulfur dioxide. Sulfur dioxide is a gas which is liberated here. So it is 2 PbO, 2 SO2 and 2 PbS and 3 O2. Balances in the same manner. Okay. So here again you are getting sulfur dioxide. Now since these minerals are roasted in large quantities for the metallurgical industry, sulfur dioxide is obtained as a byproduct here. The metal oxide will go for extraction of metals, right? And the third one we have is iron pyrite, which is FeS2. And this also on roasting will give Fe2O3, ferric oxide plus SO2. Okay, so 4 FeS2, because this is oxygen is an odd number, we have made it 2. So 2 Fe2O3, so that makes 4 FeS2, 4 to 8 SO2. And now we can count the oxygen, 8 to 16 and 6, 22. So we have 11 O2 here. So here you got sulfur dioxide again. So large quantity of sulfur dioxide is obtained by this method. So the step one of contact process is to manufacture sulfur dioxide, which we have got now, right? We will go to the next step. Step number 2. Step number 2 is the contact tower. What we do in the contact tower is conversion of sulfur dioxide to sulfur trioxide. We have got sulfur dioxide now by roasting. Now we will convert this to sulfur trioxide. What is the temperature involved? The temperature is 450 degrees Celsius to 500 degrees Celsius. An optimum temperature range is there. It should be maintained between this. And a pressure of 1 to 2 atmospheres is also maintained here. A pressure is required. And the reactants here are SO2 and oxygen. Sulfur dioxide and oxygen, two gases are involved. The catalyst used here is vanadium pentoxide. Vanadium pentoxide, that is, we can say the formula is V2O5. Or one more catalyst that can be used is platinum. is a metal, platinum, Pt can also be used, right? The reaction here is sulfur dioxide plus oxygen. It's a reversible reaction. So here we write the temperature 450 to 500 degrees Celsius. Here V2O5 and 1 to 2 atmospheres pressure. So all that is written 2SO3. The reaction, the product is an exothermic reaction, plus delta means exothermic heat is liberated. So that is the equation. Then vanadium pentoxide is a better catalyst than platinum. Why? Because the ores on roasting give impurities, because we are getting the sulfur dioxide from the ores. Impurities such as arsenic impurities. Now V2O5 is less easily affected by the arsenic impurity. So this is something we need to. The arsenic impurities do not affect V2O5 so easily, whereas platinum is affected. That is why vanadium pentoxide is a better catalyst. Now where are the impurities coming from? From the ores which we are roasting to get sulfur dioxide. Okay, right. Next, the arsenic impurities must be removed before the gases are sent into contact hour. This is another requirement. In order to have efficiency, what we have to do is, before we send sulfur dioxide and oxygen into the contact hour, we must remove the arsenic impurities so that it is safe, so that the reaction takes place at optimum speed. So that, why are we removing? To prevent the poisoning of the catalyst. Okay, poisoning of the catalyst means making the catalyst inefficient or ineffective. So just to prevent that, if the arsenic impurities can be removed, this problem can be avoided. Otherwise we need to use vanadium pentoxide, which is less easily affected by the arsenic impurity. Okay, so you understood step 2. I hope. Now the product here is sulfur trioxide. Let's go to the next step. The step 3 is the absorption tower. Absorption tower, what is done? Sulfur trioxide is absorbed in a downward spray of 98% concentrated sulfuric acid, where we get a product called H2S2O7, which is called oleum or pyrosulfuric acid. The product here is pyrosulfuric acid or oleum. Okay. Now sulfur dioxide, sulfur trioxide example, I can write this reaction also. SO3 plus H2O directly forms H2SO4. Now this reaction is not preferred. We don't prefer this reaction. We prefer this one. Why? Because sulfur trioxide dissolves in water to give sulfuric acid. The reaction is not preferred because it is highly exothermic. It is highly exothermic. It results in the formation of a dense fog of sulfuric acid. Dense fog of sulfuric acid. This fog does not settle down easily. Does not settle down easily. So this is a problem here. So to avoid this, what we do is, we do not dissolve sulfur trioxide directly in water because it is highly exothermic, right? So we dissolve sulfur trioxide in a downward spray of 98% sulfuric acid, which is highly concentrated. So the product is oleum, right? Now the oleum has to be converted to sulfuric acid. That is done in step 4, which is called the dilution tank. Here what we do, we take calculated quantity of water, cold distilled water in a large container, and then add calculated quantity of oleum to it. So this calculation is done in order to get a required concentration. The product formed is the required concentration of sulfuric acid. So we already decide what concentration of sulfuric acid we require. Accordingly, we take calculated amount of cold distilled water and calculated quantity of oleum is added to it. So the reaction H2S2O7 plus H2O will give to H2SO4. Sulfuric acid is formed. So if you add excess of water, it will be dilute. If you add minimum water, then you will get a concentrated sulfuric acid. The highest concentration possible is 98%. So that is how we get sulfuric acid. Now let's see, just have a flow chart, okay, to understand what has been happening here. Anyway, in class 10 you don't need all this description. This is just shown to understand what is happening. See, the first thing is sulfur and hot air is going on here. It is burning, sulfur dioxide is produced. The gases are sent to the next chamber. Water is sprayed here to remove dust and other unnecessary particles here, which is then sent to another chamber. Here the downward spray of concentrated sulfuric acid to remove moisture, to get dry gases. So you get dry SO2 and O2, which will go to the next chamber where it is now arsenic remover. Arsenic remover is here. It will remove arsenic impurities. Then it is tested for quality, purity, then sent to the contact tower. So this here is the contact tower, the catalytic converter. Here we have the vanadium pentoxide kept here and the gases are moving here. The product SO3 comes out from here. SO3 is then sent to the next chamber where we are spraying 98% sulfuric acid, downward spray. It will dissolve. What comes out is oleum. Oleum will be diluted to get required concentration of sulfuric acid. That's all in this. So students, I hope you understood how sulfuric acid is manufactured by the contact process, which is a large scale manufacturing process. So if you have questions, write in the comment section. Otherwise, you can subscribe and like the channel. Thank you.